Hello, I'm going to try this again. I tried many times today, unfortunately unsuccessful. Um, I just know that you guys are confused and you need me, but I'm doing my best under the circumstances. So, for this first week, what you need to do is learn very well the terminology. In other words, complementary angles, supplementary angles, acute triangles, uh, coterminal, all of that. If you want, make a list for yourself with definitions because you are going to need them. Um, Otherwise, I'm pretty sure everybody is familiar with the Pythagorean theorem as the special triangles, or they're not going to be a problem for you to learn them. You can watch videos on that. Where I think you might have a problem with is the new concept of angle in trigonometry. So I wanted to pay special attention to that. So let's say that we have a coordinate system here. I really hope that this time is recording correctly. And you have an angle. So in trigonometry, we call those angles directed angles because they have a special position. So the vertex is at the origin, and you have the two rays. Now, what you need to keep in mind is that this first initial side of the angle is fixed. It is like glued to the x-axis. The other one, this one that is called terminal, it's kind of difficult to write, but so this is the terminal side. This is the side that you can move. This one you cannot move. It's there always, so that's your starting point. Then the terminal side could be moved clockwise or counterclockwise. Now, when you're moving it counterclockwise, which means you're starting from here and you're moving this way. In trigonometry and the angles, you always have to indicate where you start, where you finish, and which direction you're going. On the homework, you have stuff like that. So every little detail matters. Now, this is a positive angle. If you're going counterclockwise, this is a positive angle. Now, if you move the terminal side in this direction, and again, you have to indicate that you're moving in this direction from the positive x-axis. So this would be a negative angle. So in trigonometry, we can have positive and negative angles. This is one thing. Another thing we can have is angles that are more than 360 degrees. They can go pretty much to infinity. And that would mean that you're turning over and over and over again. So you make one turn, that's 360. You make another turn, then it's 720, and so on. So this is different than your understanding of angles from geometry or from algebra. Um, in trigonometry, the angles are a little different, as you see. Again, remember that the first side is glued to the x-axis. You can only move the terminal side of the angle, and it's positive or negative depending on the direction. Another thing that you may have trouble with is the measurement of angles. I know you know degrees, but unfortunately in trigonometry most of the time we will have to work with radians. Uh, it is a little bit abstract and strange concept because you haven't worked probably with that concept before. What it is technically is that you work in terms of pi. So 2 pi corresponds to 360 degree. So if you go around once, again, you're starting from the positive x-axis, and you're going once, around, that is 2 pi in radians. Now, let's see how this is divided here. So this is the 0 degree and 0 pi. As you start moving around, this here would be pi over 2, or that would correspond to 90 degrees, but in pi, in radians, it's pi over 2. Right here, that would be pi. That would be 3 pi over 2. And after one full turn, this also going to be 2 pi. Now, I know it's very tempting for you to convert back to degrees and see what it is, but you will do yourself a favor if you learn the angles in pi directly. Otherwise, you're going to waste much more time. You're going to not completely understand the concept, and it may be difficult and challenging. So you should be able to manipulate everything in terms of degree and in terms of radians without having to convert between the two all the time. You also now you have to learn how to convert, of course. But what I'm saying, when later on when you work in pi, you have to stick to pi. For example, on your homework, you have some conversion and some other things. If the problem is given in radians, you have to stick to the radians, work with radians, not convert it to degrees and then convert it back to radians. You have to learn to work in radians. If I find any video online that explains it beautifully in details, I will post that video. So, how do you convert? If you have something that it's in degrees, let's say I have 45 degrees, okay? And I want to convert that to radians. The way to convert it is to multiply by pi over 180. Okay? So pi stays. Remember one thing, and those of you that had me before, I mentioned this several times for other reasons, but as well that you cannot work in decimals. Only under very, very special circumstances where there is no way around, you can work in decimals. These are not exact numbers. So when you convert, when you do anything in trigonometry, you have to leave it in fractions. So in this case here, this goes into 180 4 times. So the answer is going to be pi over 4. Now, if you want to do backwards, let's say you have pi over 3. And now you want to convert that to degrees. In this case, you're multiplying by 180 over pi. Because you are doing it in degrees, pi should cancel. That's how you know you're on the right track. Pi should cancel in this case. And that is 60 degrees. Now, as easy as that might look, I want to see the work on your homework. How you're doing it, what you're multiplying by, and so on. So this is one thing. And I think this is the most important thing this week. Of course, if you have questions or if you don't understand something while you're going through PowerPoints and other things, you can always email me. But I'm begging you to look at the announcements often and check everything often. Do not rush with submissions yet. This is it for now. See you later.